So we've been playing with right triangles and using SOHCAHTOA and Pythagorean theorem. And then we went to oblique triangles, which means, remember, non-right triangles, in which we could use the law of sines. Now remember, the only time we can use law of sines is if we have those opposites, like angle A and side A, or angle B and side B, etc. But hopefully you realize you're not always going to have all the correct information. What if you have all three sides and you want to solve the triangle without any angles? Or what if you have two sides and an angle, but they're not in the right arrangement so that you have a pair of opposites? So we have another option, and that is called the law of cosines. The law of cosines actually has two different applications that we could use, or two different arrangements we could use with it. The first one is, like I said, if we have all three sides. Now, I know when you guys see something like SSS, it's like a flashback to geometry, and you get all scared because you think about proving triangles congruent. Remember that? Like side, 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 congruence triangle, or congruence theorem, or whatever, right? That's not what I mean. I do mean SSS, but just in the way of I've given you all three sides, or you have all three side measures. Okay, that is one application that we can use the law of cosines with. The second one is SAS. So you have two sides. I'm going to go ahead and draw an example of it. So maybe you have two sides, 10 and 12, and you have an angle, but the angle is actually between the two sides. So maybe you have that angle there. Notice we don't have any opposite angle and side pairings. So that would not be a law of sines problem. This would be an application of the law of cosines. Okay, so these are the two conditions we're talking about with law of cosines. So really any triangle we want to solve, either we can use law of sines with because we've got opposites, or it fits in one of these two conditions. Okay, so everything's solvable now. And if you're wondering, there is a law of tangents. I can look it up. I don't know it because really we don't need it. Every triangle is solvable using either sines or cosines, as long as you have at least three pieces of information anyway. Okay, so the law of cosines. I'm actually going to give you two different versions of it based on which situation we're solving. You really don't need both, but I want to give you both just in case. So please don't memorize both. We need to make sure we know one of them, and then the other one just comes from that first one. Okay, so law of cosines, I'm going to start with this. So c squared, and that is a little c. Oh, let me label this. This would be an SAS form. So if you have two sides and you have the angle between them, so like this picture I drew, let's say I want to solve for that third side. So I want to solve for side C. Okay, so it starts out at c squared equals a squared plus b squared. And doesn't that look familiar? That it would be the Pythagorean theorem, people, but it's not done. So it's not just the Pythagorean theorem. So c squared equals a squared plus b squared minus 2ab, and then cosine of angle C. That is our law of cosines. Notice it has a cosine in it. Law of sines has a sine in it. And you may be like, why is she even bother telling me this? But people sometimes get them mixed up. Law of cosines has cosine. Law of sine has sine. Okay. So notice what we have. We have side C, which we're solving for. We have been given sides A and B. So those are two numbers we know. So I have a squared and b squared at the beginning of the formula. And then a and b come up again here later, same two numbers. And then we also have angle C. Okay, so all the stuff on the right side in the side angle side formula is stuff we know and that we're solving for C. Now, what if it's not side C that you're solving for? What if you have A and B? No, that would be this one. What if you have A and C and you want to find B? We can just rearrange it. Okay, so let's just write that version. So if I want to say, I want to solve for side B, but I've got A and C, so I can do a squared plus c squared minus 2, same letters, A and C, and then the angle that I must have would be the one that I've started with, which is angle B. That writing is horrible, but it's because I've got my video up and my screen's up. So basically, whatever letter you start the formula with, that side, you have that angle at the end. Those will always be the same two letters. Okay, one side, one angle. So that is any version. We could do another one for side A of the side angle side form of it. Now, let's go to something for the side, side, side. What if you have all three sides and you want to find an angle? Well, really, all we're going to do is take this first formula. I'm going to do the one with C, and we're going to solve for the cosine of C. Okay, so I'm just rearranging. I'm just solving that first equation for cosine of C. Okay, so let's think. If I was going to solve for the cosine of C, That means I started with c squared. I subtracted off the a squared and the b squared. Ooh, I gotta erase that. That's ugly. Hang on. A squared, there we go, minus b squared. So that's just subtracting those two squares over to the other side. And then I would divide by the coefficient that's in front of cosine of c. So I would divide by the negative 2ab. There we go. So again, it's not a mystery. It shouldn't be a mystery. And it's not something I want you to memorize because it comes straight from solving this equation for cosine of c. I took the squares, I subtracted them over. And then I took the numbers in front and I divided them over. Okay, so I probably will not write this. I'll write the original version and then solve that. Okay, I just want you to have it in case you do want to memorize. Please don't, and just want to go straight there. Okay, so that is our law of cosines. Again, either using SSS or SAS. So let's just solve a triangle here. Okay, so here I have two triangles, and you can see that both of these are law of cosines problems. Because if you look at the first problem, I've given you all three sides. And again, I'm going to go ahead and label stuff. So I'm going to go A, B, C. Okay. First thing I would do is check to see if I could use law of sines on this problem. Do we have a pair of opposites? Do you have an angle and its opposite side? And since we don't have any angles, then no, we don't have opposites, and we can't use law of sines. So this would have to be a law of cosines problem. Same thing on the next one. I've got two sides and an angle, but I have no opposites. So this would also have to be a law of cosines problem. We're just going to solve the first one here, just so you can see how it works. So when we go to solve, and I said this with right triangles, I want you to find the smallest piece of the triangle first, if you have a choice. Sometimes you don't have a choice, but if you have a choice, like on this triangle, I can pick any angle to solve for. I want you to go smallest first. So in looking at these three sides, the smallest angle is going to be opposite the smallest side. And since I noticed that side A is only 8, it would obviously be the smallest side, which means angle A is the smallest angle. Okay, so I'm going to use the version of the law of cosines that would help me solve for angle A. So if I'm solving for angle A, then I'm going to use the equation that starts with A squared, because I know if the equation starts with A, it ends with A. Okay, so A squared equals, and I'm just writing out the letters first. So B squared plus C squared minus 2BC cosine of angle A would be the version of the formula that I'm using. So now let's go ahead and put numbers in. So A I know is 8, so that would be 8 squared equals. B is 19, so 19 squared plus C, which is 14. 14 squared minus 2 times those same two numbers, 19, 14, and then I've got the cosine of A. Because I don't know A, so I'm leaving my A, right? Okay, solving for cosine of A, that's what I want to get by itself. I'm going to take my squared terms, I'm going to subtract them over. So I'm going to scoot this up a little bit too. So that would give me 8 squared minus 19 squared minus 14 squared equals that negative 2 times 19 times 14. Okay, once the squares have gotten out of the way, then I can take the coefficient, the negative 2 and the 19 and 14, and divide it over. So I'm going to divide it over. Negative 2 times 19 times 14, and that should give me the cosine of angle A. Okay, so that's what that second formula that I gave you was. It's this, but I just wanted you to see where it comes from. It's just solving the equation for cosine of A. Okay, now since we're solving for an angle, and again, remember I haven't touched my calculator yet, right? Everything's been written. Okay, since I'm solving for an angle, I know I'm going to use an inverse cos. So I'm going to type in second cos, and then I'm just going to type in that big thing like I wrote. Now, one thing we do need to look out for here as we go to our calculator, we are going to need separate sets of parentheses around our numerator. Oops, there goes my calculator. And our denominator. If you do not put those parentheses in there, your calculator is not going to divide the things you want it to divide. Okay? It's going to group only the touching terms and divide those, if that makes sense. So I'm actually going to type it both ways so you can see. Once I get my calculator out of the way. Okay, so inverse cos. So if I don't put the parentheses in, I would do 8 squared minus 19 squared minus 14 squared divided by negative 2 times 19 times 14. Okay? Even if I put parentheses around that. Do you see the negative 14 squared and then the divided by after? That tells me only the 14 squared is getting divided. Okay, and if I hit enter, there's an error. There's a problem. Okay, so that should tell you, oh my goodness, I must have typed something in wrong, right? We need parentheses around the tops and the bottom to group them together. So I'm going to go back here. I'm going to retype this. So second cos, parentheses for the top, 8 squared minus 19 squared minus 14 squared. Close them up, divided by, parentheses. Here comes the bottom. Negative 2 times 19 times 14. Okay, 14. Okay, there we go. See the difference? So now I can say, hey, I got the squares on the top. I got the rest of the coefficient on the bottom. When I hit enter, I am seeing angle angle A as 22.08 degrees. Okay, parentheses are important here. Group the top, group the bottom. 22.08 degrees. Oh my goodness. This writing is horrible, people. 22.08 degrees. Okay, and that would be angle A. So I can throw that in there. Okay, now we are not done with our triangle. We still have 2 more angles to find. So what would the next biggest angle be? Because that's what you want to go to next, right? We're going smallest to biggest. We got the smallest. Now think about what the next angle would be. Okay, angle C must be our next angle because it's the medium side, right? The medium side must be across from the medium angle. Now, we could reset up this equation to help us find where were we going to find angle C? We can reset this up for angle C. But now that we have angle A and side A, we have the option to go back to law of sines. So you can go law of cosines again, solve for angle C. Just do the version that starts with C and ends with C. Or we can go law of sines. I prefer law of sines just because it's a much simpler cross multiply and divide type thing. So I'm going to go to law of sines to solve for angle C. You get to make that choice for yourself. You have the option. Okay? So I'm going to go ahead and set it up. So I know both A's. So I'm going to say 8 over the sine of 22.08. Those are my A's. Equals, I'm solving for side C. So I'm solving for angle C. So I need to put side C over the sine of angle C. Okay, now we can cross multiply. So 8 sine C equals 14 sine 22.08. I know I'm going to be solving for an angle, so I'm going to go ahead and jump ahead and say, okay, it's going to be an inverse sine. It's 14 sine 22.08 over 8. Okay, if you need some more steps in there, please write those steps out. I'm just thinking the 14 and the sine 22.8 or 08 are going to get multiplied. The 8 and the sine C, so I'll divide over the 8. Okay, I'm just kind of jumping ahead because I know I'm running out of space. So I'm going to pull my calculator up. See if I can scooch it out of the way. Okay, so I was doing an inverse sine, which is covered up, but it's there. So inverse sine, 14 sine 22.08, close parentheses, divide by 8, and it looks like angle C is 41.13. Okay, so angle C, 41.13. I'm going to throw that in the calculator. Does this angle make sense? Does it seem reasonable? We already knew angle C was going to be our middle angle. It should be bigger than angle A, and it is. Okay? And then we still have one more angle to find. Now, good news is, once we have 2 angles in a triangle, we can just add those up and subtract from 180. We don't have to use law of sines or law of cosines. You can, but you don't have to. So I'm just going to pull up my calculator. If I can get these out of the way. I'm just going to do 180 minus those 2 angles, which luckily I have on my calculator, so I can just cover up my problem. It's 180 minus 22.08 minus 41. I forgot my 4. 41.13, and it looks like angle B is 116.79. 116.79. Okay, again, does it seem reasonable? Yeah, because it's obviously the biggest angle, because it's across from the biggest side. Okay, so make sure your triangles seem reasonable. Don't get big stuff across from small stuff. Big is across from big, small is across from small. So letter B we'll probably do in class together, just using that law of cosines and then sines to finish up. So That's your law of cosines. Again, either in the side, side, side type problem or a side angle side, like you see in that next example.